things today. Happy, happy birthday to me. Happy birthday to me and to you. Happy, happy birthday to me. Happy birthday to me and to you. I'm feeling thankful.
Happy birthday to one of my favorite restaurants in Philadelphia, Varga, on the corner of 10th and Spruce, and also to Chef Evan Turney. Welcome to one of Mr. Bomsey's famous math videos here at Lower Marion High School. We're going to do a brief video on limits right now, which I know a few of you probably won't stick around for, and that's okay. First question I have for you is, what is the limit as x approaches 7 of Varga? Is it Evan's Brussels sprouts, Miss May, Rich Colley's beard, or is it Matt Satin? Not really sure what the answer would be, but let's go with Matt Satin. It was his birthday yesterday. And he went to Lower Marion High School, so it kind of works out perfectly, doesn't it? All right. Anyway, how about some math? All right, so a little introduction to limits. Okay, this is for students who are not seniors, who have not left us yet. A little introduction to calculus. Okay, what a limit is generally it asks you to determine what, in the case of a graph, what y value are you approaching as x approaches a certain number. Okay, like for instance, if we wanted to figure out the problem like call it problem 1, the limit as x approaches, say, 3 of this function, what that's asking you to do is, okay, try to figure out on the graph as the x value gets really close to 3. Not exactly when it's 3, it doesn't really matter, but as x approaches 3 from either direction, what is the y value approaching? Okay, it should be kind of obvious in this case. As x approaches 3 from either side of the function, so x is 3 here, but as it's approaching 3, this is assuming we're going for a scale of 1, which we are. As x is approaching 3, you're on this part of the function. Y is approaching 1, 2, 3, 4, right? So as x is approaching 3, y is approaching 4. Y is 4 all here and here and here. Doesn't really matter. It's just that this particular problem says as x gets really close to 3, what is y approaching? Well, from this side it's approaching 4, and from this side also. So as you're, if you kind of imagine yourself driving a car along the function this way and this way, both ways, all right? If as you approach x, an x value of 3 from both directions, if y is approaching the same value, that is just your limit. That is the answer. The answer in this case is 4. Okay? The limit doesn't always exist. The limit always is going to, the limit will only exist if the y value is approaching the same value from both sides. Okay? Like for instance, in the limit as x approaches 1, if we wanted to figure out what that is, see, we're going to do a bunch of problems here because there's a lot of stuff going on with this function, and I drew it like this on purpose. Not just because of the v for Varga, but for many other reasons. So the limit as x approaches 1, that would not exist, right? Mean girls? That does not exist. You write DNE, all right, because, well, as x approaches 1 from the right, as x approaches 1 from the right-hand side going this way, and as x approaches 1 from the left, which is really going this way, right? As x approaches 1, you're going from 0, x is a half, x is 3/4, x is approaching 1 here. Well, from the two different directions, you're approaching a different value. From this side, as x approaches 1, y is approaching 2. From this side, as x approaches 1, y is approaching 4. So because there's two different values that y is approaching from the different sides, we say the limit does not exist. Okay? There's also certain kinds of problems where I just asked you for right-hand limits and left-hand limits, all right, which would exist, but the general limit, it has to approach the same value from both sides for the limit to exist. All right? Let's do another one. How about just the limit as x approaches? Let's go in the negatives. Let's say 1 to -2, right? This is -2, -1, whatever. as x approaches -2 in the function. Think about it again. You're trying to figure out from both directions on the function, as you're getting really, really close to -2, what is the y value getting really close to? Okay, so here is where x is -1. So we're going this way. We're driving along the function this way, approaching -2. Y is approaching -3 from the right-hand side, right? As we're coming from this direction, y is approaching -3. Now from this side, as we're approaching it from the left, as we're approaching -2, y is also approaching -3, right? From both sides, y is approaching -3. Now, there's not actually a point there. An open circle means there's not actually a point there. F of -2 is actually 0, right? There's a closed dot up there. So the function value, f of -2 from algebra 2, that is 0. But the limit, the calculus part of this, the limit as x approaches -2, does exist. It is -3. You're approaching the same value from both sides. So this does exist. It is -3, even though, a little side note, right? F of -2 happens to be 0, right? But that's not what the problem was asking you. It didn't ask you for the function value. It asked you for the limit, okay? So this function, we say it's not continuous. The function is not continuous at x equals -2. It has a little bit of a jump there. But the limit does exist, okay, because the value of -3 is being approached from both sides, all right? Let's do a couple more, all right? Let's go back and just do limit as x approaches 0 of this function, all right? As x approaches 0 from both sides, from this side and this side, the y value is approaching 0. You might see that, right? So as x approaches 0 from the left and from the right, as it goes, here it's 1, here it's 1/2, here it's 1/4. As x approaches 0 here and here, y is approaching the same value, and that is 0. The fact that these are the same is just coincidence, right? They certainly don't have to be the same. Do I have more room to write down here? Yes. All right. Let's just do one more here. How about the limit as x approaches -1? Right? As x approaches -1, from the left-hand side, from this side, as x approaches -1, y is approaching 2. Right? Y is approaching 2. But from this side, as x approaches -1, y is approaching -2. Okay, right? As x approaches, it's going from -2, -1.5. As it approaches -1, y is approaching -2 here, but up here, as x approaches -1, y is approaching 2. It's approaching two different values, so again, we see the limit does not exist. Okay? All right, the limit, I'm actually going to make some notes here. The limit does not exist. The limit as x approaches, let's say c, does not exist a bunch of times where c equals, well, we've already established that it doesn't exist at 1. It doesn't exist at -1, right? Think about where the limit, where else it would not exist. Well, it's not going to exist at, okay, again, it doesn't exist at -1, it doesn't exist at 1. But it also doesn't exist at 4, okay? Because at 4, from the left, y is approaching 0, right? From the left-hand side, y is approaching 0. From the right-hand side, though, there's no part of the function, all right? After 4, we're done. The domain of this function is -infinity to 4. So it ends at 4. If there's no part of the function to come from that side, then we don't have a limit. It does not exist, okay? It does exist from the left-hand side, but the general limit does not exist. All right? I believe it exists everywhere else. Yeah. Okay? So just a little bit of an introduction to limits and a little bit of a nod to one of my favorite spots in Philadelphia. All right? Have a great day.